Can you imagine a world where diseases are diagnosed and treated at the molecular level? Welcome to the realm of nanotechnology, a fascinating field where scientists manipulate matter at the molecular and atomic level. This isn't science fiction, but a reality that's unfolding right before our eyes. Imagine tiny machines smaller than a human hair working tirelessly to improve our lives. It's a world where the big impact comes from the tiniest of elements. Stay tuned as we delve into the fascinating chronicles of nanotechnology. Our journey begins in the mid-20th century with the visionary scientist Richard Feynman. Feynman, a man of considerable intellect and foresight, delivered a groundbreaking talk in December of 1959 titled, "There's Plenty of Room at the Bottom." This talk, while not directly mentioning nanotechnology, planted the seeds for what would later blossom into the field as we know it today. Feynman proposed the idea of manipulating and controlling things at an incredibly small scale, down to individual atoms and molecules, a concept that was revolutionary for its time. He envisioned a world where we could create molecular machines, devices so tiny yet so intricate, capable of performing tasks at a scale beyond our wildest dreams. He pondered over the possibilities of storing all of the world's knowledge in an area no larger than a dust speck, or of miniaturized medical robots, performing surgeries from within the human body. Feynman's theories, while extraordinary, were just that, theories. The technology needed to make these theories a reality was not yet available, but his ideas sparked curiosity, inspired countless scientists, and laid the theoretical groundwork for what we now know as nanotechnology. In the years following Feynman's talk, his ideas were explored, researched, and debated. The concept of nanotechnology, manipulating matter at an atomic or molecular scale, was becoming more than just a theory. But it wasn't until the 1980s that nanotechnology began to take shape. The 1980s marked the dawn of practical nanotechnology. It was a decade of neon, big hair, and even bigger technological advancements. And at the forefront of this vibrant era, nanotechnology was taking its first steps into the scientific world. A critical catalyst for this was the development of the Scanning Tunneling Microscope, or STM for short. This wasn't your average microscope. It was a tool that allowed scientists to see the world on a scale that was previously unimaginable. Not only could they view atoms, but they could also manipulate them. Imagine being able to move around the building blocks of the universe like pieces on a chessboard. That's what the STM offered. And as if that wasn't enough, the 1980s also brought us the discovery of fullerenes, unique carbon structures resembling geodesic domes. This was a game changer. With the discovery of fullerenes, scientists had a whole new playground to explore, a new dimension of nanotechnology that opened up a world of possibilities. Fullerenes were like the missing piece of a puzzle, allowing scientists to understand and manipulate atomic structures in ways they never could before. These developments were monumental. They were the stepping stones that propelled nanotechnology into a new era. Scientists could now interact with atoms in ways that were once only the stuff of science fiction. They could see them, touch them, and manipulate them. It was like being handed the keys to a universe that had been locked away. But this was just the beginning. The groundwork had been laid, the tools were in place, and the stage was set for a revolution. The 1980s had provided the spark, but the fire of nanotechnology was only just beginning to burn. As we moved into the new millennium, nanotechnology began to make its way into our everyday lives. From medicine to electronics to energy, the influence of nanotechnology was starting to become apparent. And as we'll see in the next scenes, this was just the tip of the iceberg. The 21st century has brought nanotechnology out of the laboratory and into the world. It's as if we've been given a new set of tools, allowing us to manipulate the very fabric of reality in ways once only dreamed of in science fiction. In the realm of medicine, nanotechnology is revolutionizing diagnosis, treatment, and prevention of diseases. Imagine tiny robots or nanobots navigating through our bloodstream, repairing damaged cells, and delivering drugs directly to the disease site. It's not a far-off fantasy. It's a reality that's unfolding right now. Electronics, too, have been profoundly impacted. The creation of nanomaterials like graphene and carbon nanotubes has opened up new horizons in computing and communication technology. These materials are lighter, stronger, and more conductive than anything we've seen before. They're enabling us to create devices that are not only more powerful and efficient, but also more sustainable and less harmful to the environment. Speaking of the environment, nanotechnology is also playing a crucial role in energy production and environmental protection. Nanoscale materials are being used to make solar panels more efficient, batteries more powerful, and fuel cells more durable. They're even helping us clean up pollution, with nanoscale particles being used to break down harmful chemicals in our water and air. In every sphere, from the clothes we wear to the food we eat, nanotechnology is making its mark. It's reshaping industries, transforming economies, and changing the way we live our lives. But it's not without its challenges. As with any new technology, there are ethical, safety, and regulatory issues that need to be addressed. And yet, despite these challenges, the progress we've made is undeniable. The advancements in nanotechnology have been rapid and remarkable, but what does the future hold? As we look to the future, the possibilities of nanotechnology seem almost limitless. It's an exciting time as we stand on the brink of a new era, with advancements in this field promising to revolutionize our world. Picture this: nanorobots, microscopic machines designed to perform specific tasks. These could be used in various applications, from cleaning up the environment to performing complex surgeries. They could be programmed to target cancer cells, delivering treatment directly to the source, thus minimizing side effects and maximizing efficacy. Imagine the potential for advanced nanomedicine. We're talking about personalized medicine, where treatments are tailored to individual genetic profiles, increasing their effectiveness. This could lead to breakthroughs in the treatment of diseases that have so far eluded us. Now, let's venture into the realm of quantum computing. Nanotechnology could play a pivotal role in the development of quantum computers, machines that leverage the principles of quantum mechanics to process information at speeds unimaginable with today's technology. This would open up new possibilities in fields such as cryptography, artificial intelligence, and drug discovery. But as thrilling as these prospects are, they are not without challenges and ethical considerations. For instance, the use of nanorobots in medicine raises questions about privacy and consent. Who controls these robots? Who has access to the data they collect? Then there's the issue of equity. As with any groundbreaking technology, there's the risk that the benefits of nanotechnology could be disproportionately distributed, leading to increased inequality. And of course, there's the environmental impact to consider. While nanotech could help us fight pollution, the production and disposal of nanomaterials could also contribute to environmental degradation if not properly managed. These are complex issues that need careful thought and responsible handling, but with the right guidance and continued exploration, the benefits could be immense. As we journey into this nano-sized world, we are only limited by our imagination. From Richard Feynman's vision to today's cutting-edge applications, nanotechnology has truly revolutionized our world. We've journeyed from its genesis, through its evolution, to its current state in the 21st century. We've seen how this technology, once a mere concept, has become an integral part of our lives, shaping industries and propelling us into a future beyond our wildest imaginings. As we look ahead, the potential of nanotech is boundless. In the realm of the infinitesimally small, we are making giant strides. The future is nano, and it is here.